Yo, do y'all think there's life out here?
I don't know, maybe. You want to go look for some?
We're not doing anything right now.
That sounds fun. Let's do it.
Mic check, mic check.
Can y'all hear me?
Yep.
Yup.
Yup.
Where would we even begin to look? Are there any other planets like Earth?
In terms of atmosphere, mass, material, size, and density, Venus is the most identical to Earth. But if we were to try to go over there, the volcanic geology would melt us and slash or crush us with its heavy composition. So it's safe to assume there's no life there.
Exoplanet Gliese 667 CC gained recent attention on its potential habitability due to the proximity of the star it orbits. Although a red dwarf star and it being not as big or bright as the sun, the distance between the exoplanet and the star emits the right temperature that allows for water to be preserved in liquid form. Unfortunately, detailed information about Gliese 667 CCs is shown specific characteristics such as its atmosphere and surface conditions, which is limited, as direct observations of exoplanets are challenging. With much of the information we have, it comes from indirect methods.
Okay, so if these planets don't have the right conditions for life to thrive, what would a planet need in order for life to thrive properly?
Currently, there is no true consensus as far as what all is required to preserve life on another planet. But using information we have about Earth, estimations can be made. For example, Earth's unique combination of plate tectonics and abundant water source are considered to be the greatest factors to sustaining life. Other elements are taken into consideration of a planet's ability to preserve life as well. Those main elements include the presence of liquid water, energy source, and the replenishment of methane and oxygen. Liquid water allows for the chemical components of life to continue over time and come together for reactions. There are also elements such as carbon dioxide, which also consists of oxygen. Thanks to photosynthetic life, carbon dioxide can be absorbed and oxygen can be emitted. Water and rocks from the Earth are also capable of trapping carbon dioxide, keeping it from tainting oxygen-rich air. All of which are what other astronauts keep an eye out for when looking for a planet that could theoretically host life. Because we cannot obtain samples of molecules from planets beyond our solar system, astronauts rely on the detection of biosignatures by using spectrograph to measure the types and quantities of gases in the exoplanet's atmospheres to find out if they were generated by life forms. Signs of oxygen, methane, and carbon dioxide in the atmosphere of an exoplanet could pose as a strong argument for the possibility of life existing on that exoplanet.
Well, is there anywhere else out there that has any of those elements?
The moons of the solar system's gas giants are also candidates for possibly habitable worlds. Saturn's moon, Titan, has a dense atmosphere, rain, rivers, and lakes that take it to the number one spot for most likely to be habitable between the gas giants. Its atmosphere is filled with nitrogen, just like Earth's, and Titan is the only other body in the solar system that has rain, lakes, and rivers. Although the lakes and rivers aren't filled with water, the abundant liquid in methane and ethane go through hydrologic cycles, leaving the possibility of methane and ethane-based life. Titan also has a subsurface ocean of water deeper below the surface, but if its hidden ocean and the surface were to ever come into contact, the complex chemistry that comes with the two mixing could result in fuel for life on this moon. Another one of Saturn's moons, Enceladus, also has a subsurface ocean underneath its icy shell. An exception of this moon is the fact that it is the only place in the solar system that has guaranteed access to a subsurface ocean without the need to dig or drill. Its seafloor has hydrothermal vents and jets of ocean water that shoot through the cracks of the moon's surface. and within these plumes, hydrogen and methane resides, suggesting that there is enough energy that should provide fuel for potential life. The third moon that has the probability of being habitable is one of Jupiter's moons, Europa. This moon has an icy shell with an ocean full of liquid water where microbes could potentially thrive in. Like Titan, it also has a rocky interior that would generate energy with the chemistry from its interaction with the water, if the water and rocky interior were to ever come into contact. So, in conclusion, we don't really know if there's life out there. There's many factors that go into keeping life alive in space, and many factors that point to the possibility of life in space, but we currently don't have the equipment to go out and find out for ourselves. So until then, we don't really know anything. Or do we?